Curious to know how insights can be extracted from IoT data to really add value, especially in industrial AI scenarios. Today, I have a couple of great guests from the company Symphony Azima AI, Sudeep and Sudhanshu. They will walk us through what it is to work on IoT projects when you're not a software or a hardware developer, as well as how Symphony Azima AI help customer extract insights from lots of data and really add value. This is today on the IoT Show. Hi, everyone. Thanks for watching the IoT Show. I'm Olivier, your host, and we have a nice show today to discuss what's going on and what happens when industrial AI, data scientists, and engineers of different realms meet IoT. So for that, we have a couple of guests. We have Sudhanshu and Sudeep. Guys, thanks for joining the show. How are you?
Very good. Thank you, Olivier. Thanks for having us.
Hey, let's start with you. Let's start with you, Sudeep. How about you introduce yourself real quick?
Yeah, sure. So I am the product manager at Symphony Azima AI. So we're an industrial intelligence company, and we build products that let industrial customers make the best use of their data. So my background is actually in building industrial intelligence technologies, all the way from industrial robotics, industrial automation, as well as big data technologies such as artificial intelligence, machine learning, and things like that. But I also have a background actually in mechanical engineering. So there's quite a few things going on.
Interesting. How about you, Sudhanshu?
Hi, I'm a data scientist with Symphony Azima AI, and my background is chemical engineering, and I work with different kind of process industries like refining, metals, cement, and develop the solutions for industrial problems and deliver to those industries.
That's interesting because usually the kind of guests that we have are whether engineers developing IoT solutions per se, or developers actually building devices. It's really rare that we have people like you guys with a totally different background. But that's actually the topic that we want to discuss today. That's the reality of IoT solutions today. It's no longer just about connecting a simple device that has temperature and humidity to a cloud and trying to do something with it. It's really about building end-to-end solutions that not only gather data from these devices, but then implement, logics, intelligence on that data to extract insight and do something out of it. But the process, the industry that this solution is applied to varies. And as you were saying, you guys have both like super different backgrounds, and like whether it's in chemistry, whether it's in physics, whether it's in data science. So I'm just curious to know how you guys seeing that evolution of these IoT solutions, and how are you, how do you become, involved in that? And how do you feel when you start working on a project for a customer? Like maybe start with you, Sudeep. What's your feeling regarding all of that?
Yeah, I think it's really interesting. So the way I got started in IoT was really I was working on industrial automation problems, industrial robotics problems, and I was delivering software and hardware for different customers to solve different problems. However, at that same time, there was a real proliferation of a lot of these IoT devices, and over the past couple of decades, we've seen computing as well as telecommunications also exponentially grow. So all of our customers wanted to collect more data, do more with their data, and it was just a logical sort of next step for a lot of the things that I was building, a lot of the technology I was building, to actually bring in these aspects of collecting lots of data and processing it in real time and being able to do more than just some static logic that runs on a PLC. They wanted more intelligent solutions, and that's basically how I got started with IoT.
Nice. And question for you, Sudhanshu. Did you know anything about coding before, or did you know anything about the cloud before getting into that job?
Very interesting question, and the answer is no. So, by education, I'm a chemical engineer, and when I started working in industry, I didn't have any exposure of coding, any exposure of cloud. So, I was doing engineering stuff. I was kind of designing the equipment. I'm preparing the process flow diagrams, piping and instrumentation diagrams. But later, as I progressed my career, and I was working in lab, so I was conducting experiments, getting the outputs of the experiments, and that's where I came across data science. So some of the experiments what I used to do in lab, it used to take hell lot of time. So for example, one experiment used to take 6 to 7 hours to generate one data point, right? So if I have to do a lot more of such experiments to a large scale, then it is very time consuming. And so that's where I started doing that. I have already generated a lot of data in the past years, and then I developed a model, a machine learning model, and then certain features I can just input, and then I can get very close result to what I was generating using the experiments, and that's where all the data science work started. And then I got more interested into it and started exploring and also started coding. So I learned Python and then started coding in Python, and later completely moved into data science field. And since I had a background in chemical engineering, I was very good fit for working in the problems in industrial domain. So I started looking into the several industries and problems, and then understanding these problems and how can we solve together with the data science, IoT, and then I come across this company, Symphony Ajima AI, where I'm working for last 3 years.
Nice. This is fascinating. I have the habit to say, there's never been a better time to be an engineer. And I'm actually not specifying whether it's software, hardware, or whatever else engineer, because actually you get to do more than what you studied for at the end of the day, right?
That's right.
Great. So you mentioned both of you work for Symphony Ajima AI. So I want to know more about what the company is about, what you guys are doing, so that we can understand, how your skills are used to help our joint customers implementing solutions to transform their business. So let's talk about Symphony Ajima AI, guys.
Yeah, so I'll give you a quick overview. So we, as I said earlier, we're an industrial intelligence technology company. So that means that we build products that help our customers, who are mainly in the industrial realm, do things like reduce operating costs, improve quality, improve safety, improve throughput, and things like this, right? So basically run a more efficient business. Now, running a more efficient business, optimizing businesses, has existed ever since businesses have existed. So what's new here? So this is, again, what I was talking about. We've had a data revolution where we've had computing, telecommunications, sensors, and even the big data processing techniques really rapidly progress over the last decade or so. And so customers are looking for that extra bit of value to unlock using their own data. Now, a lot of our customers actually already have a lot of data that they collect, but they haven't been able to sufficiently use that data to unlock value for themselves. So this is where we come in. We come in with products that can basically optimize your business in different ways. And in order to do that, we actually have 3 pillars in our company. And the main pillar, the absolute, real foundation pillar is deep domain expertise. So this means, it's people like Sudhanshu who have a lot of knowledge in process industry. We have engineers, chemical engineers, mechanical engineers, we have vibration analysts. So a lot of related disciplines to, actually being able to optimize an industrial process. So that's our first pillar. That is supported by another pillar, which is people who are, really conversant with big data technologies such as artificial intelligence, machine learning, controls, optimization, things like that. And both of these 2 pillars actually is what really helps customers unlock the potential in their business. And then, of course, in order to deliver our products, we have our third pillar, which is software. And so we have to have a great software foundation to be able to deliver the products that our data scientists and engineers come up with.
You guys must have a very diverse company. That's pretty interesting.
Yeah, definitely.
So can you share with me a bit, how you're doing that? What are the stacks that you guys are using and putting together? And I know you came with a slide to explain all of that. So can you tell us a bit about that?
Yeah, absolutely. So I have this slide up here. So this diagram is really representing what we do at a very high level, right? So there's basically 3 steps. The first step is getting data, right? And then the second step is analyzing that data. And the third step is delivering that data. So we have, a lot of different data sources that we have to get data from. Industrial companies store their data in many different formats and many different systems, and we have to be able to get all of that data somehow, store it in a homogeneous way so that we can do analysis on it. And then our data scientists and engineers have to, do things to the data, like they have to transform it, they have to contextualize it, right? They may have to also run some machine learning algorithms on them, right? And then all of that data has to be displayed in some way that is intuitive to the end user. And our end user could be a plant operator that's literally working on a particular machine or a particular process on the plant floor, but it also could be a C-suite, executive in the boardroom, right? So that is basically the flow of our company. And as you can see in this diagram, you'll see that we need storage, we need compute, right? We need transformations. We need a lot of messaging, so data has to move from one place to another. And we need things like being able to connect to data sources that might actually only be at the plant site. So we might need devices on the edge as well. So there's a very wide variety of technologies that we use to make all of this happen.
Okay, Sudeep, thanks. Great overview. I think our engineers, the typical guys that usually come to the show and build the solutions, they understand what you just described, all the blocks, all the technology that are in there. They usually build these applications. But I think as all engineers, we like to see where our work is applied. And so I think what would be interesting is for you, Sudhanshu, to walk us through an example of one of these solutions you've been working on for a customer so that we can see how that looks like to work as a data scientist, as with a different background on IoT solutions.
Sure. And I would like to take an example of another customer, and that is a glass manufacturing customer with whom we work to optimize the glass furnace. So before I go to the problem details, I would just very briefly explain how the glass is manufactured in the industry. So they take the raw material, and the raw material is mostly the silica and limestone, and then it is put into a glass furnace, and which works at very high temperature, and then it is being melted, and after the molten raw material goes for further processing, and then finally get into a mold where they blow the very compressed air, and then the shape of bottle is being made. And once that bottle is being made, again it is sent to another heating and cooling process to make it more resilient and good quality product. So that's how this entire process works. But I see that this is the melting process where this furnace works, and this happens at very high temperature, and this is very important at kind of heart of the entire glass manufacturing process. And if this temperature of furnace is not maintained very well, what it impacts the quality of the product. It also impacts the overall energy consumption. So plant can consume a lot more energy for producing the same amount of glass. So it's very important to control the temperature at controlled manner and a very tight range, So at this plant where we started working, so the situation was that there was data coming from multiple sources. So there is data coming from production, quality, furnace data, DCS data, and then operators have their own logs. So they keep looking at all this data and then take a decision that what could be optimal set point. So what they control is they control the fuel. So how much fuel they want to add to the furnace, and also they control the air, right? So for burning the fuel, you need air. So how much air they have to put into the furnace, right, to control the temperature. So as the operator works into manual mode, operator does kind of reactive kind of approach, right? So he see that that temperature is going high, and that point he gets into the action, and then he cuts the fuel or cuts the air. But since this entire furnace process is slow, temperature keeps rising, and then before it finally kicks in, and then it starts reducing. But in that process, what happens that the tight control which you would like to have, that is gone. And then, as I explained earlier, it has a bad impact on quality. It has bad impact on the overall production capability. It has bad impact on the energy consumption. So here what we did to solve this problem, we have taken all the data which is coming from different sources like production, quality, furnace, and operator logs together. We consolidated all the data together, and that's where we have used Microsoft IoT technologies, and that helped us to very quickly put all this data together and get it available to data scientists and domain experts to work on that data. And what we build is a AI digital twin of the glass furnace. And what I mean by AI digital twin is a data-based AI models, and basically it mimics the behavior of the furnace. And using this AI digital twin, we were able to forecast the temperature profile of the furnace with great accuracy in future several hours. So with that capability in hand, we had a very good understanding that how the temperature is going to change for the furnace in near future. And then we had this the optimization, AI optimization model, which works on top of this digital twin model, and it does take care. It does take consideration of all the forecasts the model is making, and then it calculates the most optimal set point parameters, like I told, fuel and air, such that temperature being maintained in a very tight range. And once that is available to the operator goes and enter that into a DCS system, and then plant runs in a very smooth manner. And these temperatures were controlled in very tight range. There won't be any excursion in the process. So to display all the outputs, to make it available to operators, we have created a Power BI dashboards, and all the information which is coming out of this digital twin and the AI optimizer, it is being displayed on a Power BI dashboard, which was sitting in the control room where operator is using it. And we also build a mobile version of it, and then anybody in the plant can go and look at the mobile screens and look at the predictions and all the recommendations what model is giving. So once we implemented this and operator started using this solution, and they started implementing the recommendations we are providing, so what we observed that energy efficiency increased up to 3%. Production has been increased up to 5%. And then if you translate all this into the economic impact, then we had almost like up to 3 million per year of impact of the medium sized kind of 55 to 60 tons per day plant. So this is a brief introduction to one of the solutions we have implemented in the customer. We work very closely, and we have validated also these results.
Nice, nice. And I can see the outcomes and the impact are pretty significant, because I guess, this kind of glass manufacturing facilities, having an increase in revenue of that magnitude, I guess, is significant, right?
Yeah, it is. Yes.
Awesome. Well, I was very interested. I think this is fascinating to see. We're used to on my show usually talk about the development of hardware and connecting to the cloud, and very often we just bypass this notion of how you extract the insights from the data that is collected from different sources, including the IoT one. So I think it was super interesting. I would invite everyone to learn more about Symphony Azima AI, which is your company, going to the website directly and just put the link up there. And well, thanks a lot, Sudeep, Sudhanshu, for sharing your experience. It was really interesting. And well, everyone, I hope to see you soon on the IoT show again. Have a great day and see you soon. Bye.